Cool. So yeah, again, thank you all for joining us today. We are the CIWEM Central Southern Branch Committee, and this is our webinar on storms, sewers and silence, the hidden pressures holding back river restoration. So before we start, we'll just go through a bit of general housekeeping. So if you have the next slide. So this webinar will be recorded, and then in a few weeks it will be posted onto the CIWEM website and the CIWEM YouTube channel as well, where you'll be able to go back and watch the webinar again. If you have any technical issues, please raise your hand and use the chat feature to let us know, and we will try and help you there. And we'll also, for any questions, be taking these at the end of our presentation. And please use the Q&A facility in the chat to pop your questions in. And you'll get 1 hour of CPD through this webinar, but CIWEM don't publish official CPD certificates. So next slide, please. So just a bit about CIWEM. So we are a Royal Chartered professional body and independent charity. So here's just some links to the CIWEM website, how you can gain CIWEM membership, and some of the CIWEM policies and publications. And Emma's going to be posting these into the chat if you wanted to take a look in your own time. So who are we as CIWEM? So as we said, we're a professional body and charity with the mission to improve the water and environmental management for the public. So we're a community of practitioners and visionaries working on a variety of issues such as climate change, resilience, the built environment, and improving water security. So we're a worldwide organisation with over 11,000 members. We're in 89 nations and 57 organisations and universities. And now I'll be passing over to our first speaker, Jed Ramsay. So yeah, thank you, Jed.
Thanks, Charlotte. Hello to everyone. Thanks for having me today. I'll start with a little bit about myself. So I've been working on rivers for 20 plus years now, managing projects like reducing flood risk, restoring rivers, reconnecting floodplains, increasing biodiversity. And generally, I'd like to think making the world a bit of a better place. These days, I work for Thames Water, and I'm dealing with this. I don't know if you can see that, but that is a sample of raw, untreated sewage taken from a small sewage treatment works that I work on in Oxfordshire, taken just yesterday, actually. And at Thames, we've got 351 sites that take that and turn it into this. And this is what you call final effluent. So this is what's released into the rivers. Before I dive into that, the big issue that we've been talking about in the news a lot is storm overflows. But before I really get into the detail of that, let me take you back in time. So you might not recognise this chap, but he's Sir Joseph Bazalgette, and you could argue he's the same to sewers as Brunel is to rail. If it wasn't for him, we'd probably still be dying of cholera and diphtheria. He essentially invented modern city sanitation in London, and which followed an event in 1858 called the Great Stink. Again, you might not have heard of this, but 1858 was a really dry year, a bit like last year, actually. A lot of sun, very low flow levels in the River Thames. And this was before there was any sanitation in place. And the Thames became to stink so badly that Houses of Parliament had to close because it was unworkable to be in there. And I guess the second the MPs started being affected, then they decided to do something about it. So they commissioned Bazalgette to deal with the issue. And the comparisons with Brunel can start there, really. So the system that he designed and built has been imitated around the world. It was over-engineered. So at the time, London's population was about 2 million. He designed it to cope with the growth of double that up to about 4 million. And the legacy of it is still with us today. So a lot of the combined sewers that you can see in the picture there, they are still being used today. For example, the Albert and Victoria embankments are built on top of those combined sewer outfalls. Now, the problem with the system that we know is that when it rains, the rainwater enters the same system, then combines with the sewage, and then it's discharged untreated straight into rivers. Of course, the flip side of this that perhaps is talked about a bit less is if they didn't have that capacity to combine in that way, the sewage system would back up and cause flooding. And of course, for anyone who's ever worked in flood risk management, sewer flooding is the worst of all types of flooding. So what's the scale of the problem that we're talking about here in terms of the storm overflows? So there's 14,000 of these in England. Thames, we've got 590 of those. And those 590 account for the figures you can see there, 14,000 spills a year on average. And it works out about 22 per overflow. Just to give you a bit of an international perspective on that, Germany has 66,000 storm overflows. America has 9,000. So we're kind of in the middle in England. And what are we going to do about it? So this is looking at it nationally. So DEFRA set a target to reduce the spills down from 22 a year to an average of 10 a year, with an average of 3 at bathing water areas. The target that Thames we've agreed with to work to over the next 5 years is to get down to 17 as an average. And now that's going to cost, we think, around 800 million to do that, to reduce it down to that. And we're going to be focusing on using nature-based solutions where we can. It's thought that this is probably the biggest program in the world. If you look at it nationally, obviously not just Thames, but all the water companies, they're investing around 10 billion in total. And yeah, prioritizing bathing and chalk streams is the other thing. So how do we actually technically go about reducing storm overflows? So the simplest way is to separate out stormwater from surface water from your sewage, and that's the one at the top of the triangle there, source control. So you might think, why not just do this nationally across the board? And that has been looked at as an option, but the cost of doing it nationally, particularly through London, has estimated about 600 billion. So it's not really a cost beneficial way of approaching it. And of course, the solutions are actually more complex once you get into the detail of it, and generally need a combination of these options depending on the catchment. So we've got things like blue green corridors, reducing the runoff, using nature-based solutions, and then the bottom two are your more traditional, increasing capacity at sewage treatment works and within the network. So the aim of spending this 10 billion is obviously, like I mentioned, chalk streams. So this is the test to make a difference on beautiful rivers like this. And it clearly will. But I do wonder whether we could do more through looking at a combined approach here. So Emma, I've got a poll coming up on the next slide, which if we get the technology to work, hopefully you can actually have a go at that. Just let me know when it's up on the screen. So just to go back to what the question is, so going back to the final effluent here. So out of the 351 sewage treatment works, if you add up what is released from each of these, as an average, obviously, which one of those do you think it is? I'll give you a couple of minutes to put your votes in. Charlotte or Emma, I don't know if you can tell me the results when we've had enough votes, because I can't seem to see them.
Yeah, so we've got about 60% have voted so far.
Okay.
And the leading vote is C, the 27,800.
Okay, thanks, Charlotte. Yes, most of you are spot on. It is 27,800 litres per second, or around 28 cumex, if you want to put it in a more typical river flow measurement. So what does that equate to? So to give you some perspective here, the River Thames at Teddington, its average dry weather flow is about 65 cumecs. So, and the green there's the combined outflow from the 351 sewage treatment works. And the smaller one I've got there is the storm overflow. So the mean average active outflow from those storm overflows that we talked about. Just to give you a bit of a visual feel for what this looks like. So this is Teddington Weir, for those of you who don't know. It's just on the west side of London. It's the end of the navigable Thames and the start of the tideway. And beautiful spot, actually, if you ever get a chance to go down there. So what we're talking about here is the total sewage flow. That is about 40% of the flow in the Thames at this point. Obviously, in reality, it's not 40% because the interactions with groundwater, evaporation, and everything else in between the release of sewage treatment works and it getting down to Teddington, it's not quite that figure. But I'm just trying to give you a feel really for how much flow comes out of the sewage treatment works, goes through and is treated. So I guess a subsequent question to this is, the storm overflow came to only about 2.3 cumecs, right? So is that really significant? Should we be spending the, 10 billion nationally that we're talking about, 800 million at Thames? And the answer is yes, it is significant because obviously untreated sewage has a much greater negative impact on rivers. So just to give you some idea for that, the biological oxygen demand is about 1.5 times higher than usual. It has ammonia about 2.5 times higher, and pathogens are 60 times higher. So dealing with storm overflows will have a huge, positive impact on rivers. I guess what I'm focusing on here is, can we do more with the 40%, the green, the total treated sewage here? And that is what I get to do with my day job. So this is that's a picture taken from the site where I got the sample. It's called Watlington, where we're currently upgrading the site for around 12.5 million. The site deals with a population of about 3,500. And I mean, me personally, I've got probably about 60 million total worth of projects to do things like this, upgrade sites, improve the quality of the final effluent, and increase the capacity. And when you look at this across Thames, it's actually, we think it's the biggest scale of investment that we've ever done in 150 years as an organisation. So it's about around 1 billion is going into upgrading and improving the outflows. And it's about 101 out of those 351 sites that we're working on. And a key element of all of this is phosphorus reduction. So phosphorus is kind of one of has one of the greatest negative impacts on rivers in terms of sewage discharge from sewage treatment works. And phosphorus comes from all of us. I mean, I personally produce about 1 to 2 grams of phosphorus a day. Domestic sources are the largest sources, depending on the catchment, but typically 60 to 80% of phosphorus comes from domestic sources. And there's a national target to reduce phosphorus by about 50% in the next 5 years. Again, huge amount going into this nationally. If you look across all the water industry, it's about 6 billion that are going into reducing phosphorus alone. So how much of an impact is this going to have? If we look at the sector, so this chart here I've taken from a really excellent report that came out in 2024 by the Rivers Trust. It's based on data from the Environment Agency. And you can see that the blue is the water industry. This is negative impacts on the river, essentially. And we are a massive part of the picture. So the total I've talked about, the 10 billion plus the other 6 billion, 16 billion that we're putting into storm overflows and sewage treatment upgrades combined is going to have a huge impact. Positive impact for rivers. Really, really good. And, I feel like it's the start of the ship turning in the right direction. Obviously, we'll probably need to sustain that level of investment for a significant amount of time to really get to a point where we're, happy with the discharge from our sewage treatment works, I think. But the bigger question, of course, is are we mirroring this investment in the other sectors? And this is another chart that I've taken from the Rivers Trust report. And it's to give a feel for the other impacts on rivers and what we can or could be doing about them. So, and I mean, actually, in the report from the Rivers Trust, they state that there's no single stretch of river in England which is in good overall health when you look at it chemically and ecologically. Well, I might just restate that. So there's no single stretch of river in England in good overall health. I mean, it's quite a shocking situation we're in, really. And obviously, storm overflows and final effluent are a huge part of that. But then you've got to think about all these other activities that have equally negative impacts, farming, highways runoff, which Joe's going to touch on in her presentation following from me. Abstraction is another one, invasive species, and so on. And personally, one in my career that I've dealt a lot with is dealing with historic river works. So, every river in England is heavily modified with weirs. They've been straightened, they've been dredged. And so there's one thing improving the water quality, and then you've also got to improve the physical condition of rivers to really get to a good place. So there's a lot of work to do, and I do think there are some good examples around the country of where a catchment-based approach is being applied. Because at the moment, the work I'm talking about that water companies are doing, it's very specific and it's honed in on the impact that water companies have, rightly so. But if we're really going to make a difference, we do need to look at the holistic picture and work at a catchment level. I think there's good examples in the Cumbria, some on the River Severn that I've come across as well. And there's a project on the Chest that I was involved in the last few years, again, looking at it at catchment level, getting all the partners together and trying to work together in a coordinated way. The difficulty with all these types of projects is, in my view, there's no legal requirement to do it. So each organisation, be it the water company, be it the Environment Agency, local councils, and everyone else that impacts the river, doesn't have a legal duty to do this work. They're done on best endeavours, and quite often, the enthusiasm and willingness of staff to get these kind of projects off the ground. If we really want to make a difference, we've really got to be looking at this working together at a catchment level, in my view. So I guess in summary, I think there's going to be massive progress made in the next 5 years with storm overflows and sewage treatment, which I'm genuinely really proud to be a part of. But we've got a really long way to go till we can truly improve river health at a catchment level. Thanks for listening. Now I'm going to pass over to Joe. I'll stop sharing slides. I'll let you take over the driving, Joe.
Thanks, Jed. I've just also answered one of the questions somebody's asked was about your pie chart and why it didn't add up to 100. And I've put the link to the Rivers Trust report, and you can see if you read the figures, why it doesn't add up to 100. It's because it's water bodies that have at least one length that is polluted from that source, so it can add up to more than 100. You can perhaps describe that more clearly than I did.
Thanks, Joe.
Just put this on slideshow mode if I can persuade it to do that. Good. Can you see that, Jed?
Yes, that's looking good, Joe.
Excellent. Thank you. So let's see if it'll go back. There you go. So I'm going to talk just to build on what Jed. So Jed sort of told you the story of sewage pollution and how the water companies are investing in reducing pollution from sewage sources. And as the pie chart showed, there are 3 primary sources of pollution in the UK: urban and transport, sewage, and agriculture. Now, I dispute that pie chart anyway, so don't worry too much about what the numbers said, because the data that's used to create that pie chart comes from pollution incident reporting and the river basin plans that the Environment Agency creates. But because nobody ever reports pollution from highway runoff very much, mostly because it happens when it's raining, I think that pie chart is wrong. I think the piece of the pie assigned to pollution from highway runoff should be much bigger. So don't get too hung up on pie charts. So I'm going to start with this slide, which just helps us all move forward at the same time to the same place. We know that highway runoff causes pollution. So this is an outfall off the M6 near my house. I've sampled this on a number of occasions. It causes pollution of the River Lostock, and that is unquestionable. So it's a good place to start. It saves me having to persuade you of that. I can tell you categorically that it's causing pollution. So what are we going to do about it? So this is the sort of pollution that it causes. And you can see this data in a report that I'll share at the end. So don't worry too much if you haven't got time to look into it in detail just now. But the column on the left shows the pollution in the motorway outfall, that outfall I've just shown you the photograph of. The column on the right shows you the pollution in the River Lostock upstream of the motorway. And there's already a little bit of pollution there because there's an Asda car park draining into it and a couple of other roads and another motorway outfall right at the top of the catchment. So you've already got a little bit of pollution. And then the middle column that I've highlighted shows the River Lostock downstream of that motorway outfall. And the red boxes signify failures of the environmental quality standards for those particular chemicals. The reason that's important is that that immediately tells you that that outfall is contributing to a failure of the environmental quality standard, which means that it's A, causing pollution, and B, illegal. So it is illegal to discharge poisonous, noxious, or polluting matter into a water environment such that it causes harm. And the fact that it's failing the environmental quality standard immediately tells you that it's causing harm. So we know that highway runoff causes pollution. Interestingly, that was polyaromatic hydrocarbons in that previous slide. The other pollutants that are in highway runoff, one of the major pollutants is metals, toxic metals, mostly copper and zinc, but others as well. This is a sample I took from an outfall in Preston near my house off a main road. This wasn't a water company, this wasn't a motorway, this was just the main road going into Preston. The bottle on the left is the sample we took. The bottle in the middle is just an aliquot of that sample, and the bottle on the right we had filtered through a 0.45 micron filter. And the chap I was with from the county council was like, woohoo, we fixed it. And I was like, woohoo, no, we haven't. Because you can see in that column on the right that there is still the levels of dissolved metals in that bottle on the right are still in excess of the environmental quality standard. They are still at levels that will harm the fish and insects that live in the river. So even if you remove all the sedimentary and particulate pollutants, highway runoff is still poisonous. And there are other things in there as well. So as you can see on that list, we've mentioned the toxic metals. And actually what one of those slides said, and I forgot to mention it, is that CEH did some research a couple of years ago that said that one of the primary reasons why British rivers are not recovering at the speed that they should is copper and zinc pollution. So copper and zinc pollution is hugely important. Jed and I could have an argument as to whether it's more important than his sewage, and there's a whole piece of work in there. Polyaromatic hydrocarbons, I just showed you in the little red boxes, they cause pollution and they are in highway runoff as well. But these little beasties, these are microplastic tyre wear particles in this photograph, taken down a microscope. And these are the little bits of rubber that come off your tyres as you're driving. And these are grossly polluting too. And there are estimated to be 63,000 metric tonnes a year of microplastic tyre wear particles coming off British roads. 63,000 tonnes a year of these little beasties getting into our water environment. Now, they are toxic in their own right. They leach out toxins. They carry toxins with them. So the little toxins stick to them and get carried into the water environment. And creatures eat them because they look like food. So that means that they take the toxins into their body, the toxins leach out in their body, and also it can affect them physically because it can block their gills, it can make them think they're full and they stop eating. So really hugely harmful to river life, but also hugely harmful to marine life. So just nasty, insidious pollution. And oddly, I say this, but it's slightly odd for me to say, part of the problem with this pollution is it doesn't kill everything. If the highway runoff went into a river and killed everything, we would have fixed it 30 years ago because we would have thrown our hands up in horror and it would have been dealt with. But it doesn't. It causes these nasty, sublethal, insidious harms that affect the population in the river and affect the ecosystem but don't necessarily kill everything. So if you count the insects in a river downstream of a motorway, you will find insects. There's little mayfly nymph there. But the fact is that those insects are affected. They can have deformities, mutations, failure to thrive, failure to grow. Their behavior is affected by the narcotics in some of the narcotic effects of some of the pollutants. Their metabolism is suppressed. They can have abortions. The eyes of fish are deformed at the embryonic stage. So fish are born with deformed eyes. All these multiple sublethal effects suppress that population of insects. And that then goes on to suppress the entire ecosystem because the insects hatch and birds and bats survive on those insects and then the things that eat the birds and the bats and, you know, all that. So we've published all that in a report and the link is there. And if I get a second at the end, I'll put it into the chat so you can download and read that report. And it goes into all this in a great deal of detail. The other thing that's in highway runoff, we don't really know why, are fecal indicator organisms. So some of the samples, we've not taken very many samples on this. It's difficult to sample and it's difficult to get research funding for. But when we have sampled highway runoff and analysed it for fecal indicator organisms, the levels have been astronomically high. We don't really know why, because the samples that we took were from the M6. And generally speaking, people don't poo on the M6, or at least I hope you don't poo on the M6. We think that it's roadkill and bird and rat poo going into the gully pots and into the drainage infrastructure and then festering. There's a great word. And it festers in the bottom of the gully pot. It's warm, it's wet, it's aerobic, and bits of it are anaerobic. So you've got all this lovely microbiological soup stuff going on. We think that's what's happening, but we don't know. So here's a huge source of pollution. So poor old Jed works for Thames Water. The Environment Agency scrutinise their every move. And they have permits for their sewage works and permits for their overflows and permits for everything. And they are scrutinised and observed rigorously. Highway outfalls. This is another highway outfall. This one's in Cumbria. Goes into a beautiful stream up off the A66. They're not controlled, they're not monitored, they're not regulated, they're not permitted, they're not measured. Nobody really knows where most of them are. It's just very odd. Same regulatory framework, same environmental quality standards, same regulator, Environment Agency, same sort of river pollution. So it happens when it rains, it causes toxic harm, reduces dissolved oxygen, increases conductivity, causes the same sort of pollution. I would argue it's worse pollution than sewage pollution, often because it's toxic and it has these bioaccumulative, long-lasting toxic effects. We know it causes marine harm, which again, standard sewage pollution, not so much, but it's not regulated. Now, the philosophy is, and some of you probably know this, is for a polluting discharge like that, the Environment Agency says to the polluter, you must apply for a permit. And the polluter pays about £8,000 and applies for a permit. And then the Environment Agency calculates the pollution, calculates the dilution available in the receiving watercourse, and then works out, using water quality modelling, how much treatment that outfall must receive before it enters the river to prevent pollution and harm. That's the process. That's how it should work, but it doesn't. And there isn't a single highway outfall in England and Wales that has a permit controlling its activity. I don't know. Well, I do know a little bit why, but if you really want to know why, you need to ask the agency. Part of the reason why is because National Highways and the Environment Agency have a voluntary agreement, and that allows National Highways to decide for themselves if their highway outfalls pose a risk of pollution. And to do that, they use an old risk assessment model that the Environment Agency and National Highways built together. I think, and this is my personal opinion, that the model doesn't work because they say that of their 25,000 outfalls, only 250 need mitigation. And yet every single time I've sampled a motorway outfall, it's been causing pollution that has contributed to an environmental quality standard failure. So I don't know why there's such a mismatch. But it's not just National Highways. Local authorities also own probably 1 million highway outfalls, and they're not regulated either. And the water companies, sorry, Jed, also own lots of surface water sewers, and those discharge into the water environment as well, and they take with them highway runoff. So this is an outfall that belongs to United Utilities. It takes the runoff from the A6 going into Preston, which you can see in the background, and all that road runoff goes into the river via the water company surface water sewer. They're not controlled with permits either, but at least they feature in the drainage and wastewater management plans. So there might be a plan in place, a cunning plan. So remember that it's not just national highways. There are other people causing pollution as well. The other thing to remember is it's not just rivers, it's also groundwater. So this is a drainage ditch at the side of the A3M in Waterlooville in Hampshire, I think, but I wouldn't swear to it. And the road here, the A3M, all the runoff from the A3M goes into that ditch. The rubber berms are there to encourage the water to soak into the ground. And the ground, as you can see, is the chalk. There's no soil activity. There's no microorganic soil with nice organic load for lots of microorganic activity. There's not very little plant growth to take up the nutrients. There's very little opportunity for sedimentation because the sediment will go into the chalk. Gross pollution of groundwater, completely unregulated. So if you're in a groundwater catchment, think about that. Nobody measures it. Those are the samples, those are the bottles from that very first slide I showed you with the upstream and downstream results. You can see the upstream bottle on the left and the downstream bottle on the right, and it doesn't take a rocket scientist to tell you that that's causing pollution. And you can see the extent of pollution in the motorway samples in the middle. The Environment Agency don't take those samples. I took them. They don't have any monitoring points on their monitoring network that are specifically located to measure pollution from highway runoff. They don't routinely measure for polyaromatic hydrocarbons in all rivers, so they don't necessarily find the pollutants that are from highway runoff. Many of the monitoring points are far, far downstream from the motorway, so you won't pick up the pollution anyway. And you have to monitor in the rain to take these samples. I have to go out in the pouring rain. My rule of thumb is that if it's raining so hard that you don't want to go out, that's when you go out, because that's when you get the worst pollution. And the Environment Agency, although routinely some of their samples are taken in rainfall just by default, they don't actively sample in the rain to measure rainfall-dependent pollutants. So we've got to fix this. This photo isn't mine. It's from Toby Hull at the Wandle Trust. This is a discharge of highway runoff into a chalk stream, and you can see there it's so stark, the difference between the pure, clean chalk stream river and then the blooming highway outfall. So 3 primary sources of pollution, and we have to fix them all in parallel, or we'll turn around in 25 years and go, well, our rivers still aren't clean, despite the fact that the water companies have spent over £100 billion. What did we do wrong? And this will be the answer. But we know how to fix it. So this is a retrofit SUD scheme in Sheffield called Sheffield Grey to Green. If ever you're in Sheffield, go and see the SUDS devices. They are beautiful and fabulous and really well designed and delivered. So the runoff from that road goes into that rain garden. The sediment settles on the surface, the plants take up the nutrients, and the hydrocarbons are broken down by microorganic and sunshine activity. Fantastic for all local roads, town roads, rural roads, link roads. I don't care, they are fantastic. But if you're national highways and you have a motorway, rain gardens aren't the thing. They're just not beefy enough to deal with the level of pollution you get off a motorway. At that point, you have to have a properly designed multi-stage treatment scheme that will include SUDS, will include nature-based solutions, but not first. You must take some of the gross pollution out first and then ask nature to do its thing later on. And all those outfalls, all those sources of pollution need to go in the river basin plans so that we drive this work forward. Thank you. I'll leave that up for a second in case anybody wants to scribble down my email address, and then I will go on to questions and hand back to Charlotte.
Thanks, Jo. Yeah, thank you both. That was 2 really interesting presentations. We do have quite a lot of questions that have come through, so I will just start on those now. And if anyone has any more questions, just remember to pop them in the Q&A box. So firstly is one for Jed. Is Thames Water target for CSO spills at bathing water sites the same as DEFRA's national target of 3?
Ooh, good detailed question. I don't know that they've set specific targets like that for bathing waters by location. Thames, we've got 3 or 4 bathing waters officially designated. I know some going through the process at the moment, so there's likely to be more. As a company, we want to have 0 spills at bathing waters. That's what we're aiming for, but I don't know that we've been specifically targeted with achieving 3 or 0, but certainly what we're hoping to get to is 0 for bathing waters.
Thank you. Next one, also for Jed. How did you quantify the annual volume of storm overflow? This is not normally measured, and how confident are you in this figure?
Yeah, good question. I didn't. So all the data I used in my presentation, I've taken from publicly available sources. And most of the data, such as those figures, came from the work that was done by DEFRA actually in the storm overflow policy and guidance that's come out over the last few years. And yeah, absolutely right. It's not measured. What's measured is it discharging or not? And that's how you get that total number of hours discharge where storm has been discharging. Yeah, so that figure of, I think, what was it, 2.3 cubics, is that accurate? Who knows? Probably not, would be my thought, because like you say, it's not measured accurately. It's an estimate at best. But I mean, when you go to sites, so like the one that I working on where the samples came from, Watlington, there's a storm discharge system. If you've not been on one before, it's perhaps not what you think it is on a normal site. So outside of London, surface water and sewage is generally separate. It's not combined the way that it is in London. So when it rains, what happens? So I talk about Watlington as an example because I know it well. You'll see an immediate increase in flows coming into the site, and then there's storm tanks that will, once it goes beyond the capacity of the site to manage, that excess flow goes into storm tanks, and then you hold as much as you possibly can in there. With the idea being, once it stops raining, you can then send what you've stored through the sewage treatment works and treat it. And the sizing of those tanks is, set really specifically. But of course, if it rains too much, those tanks can only hold so much, and that's when you end up discharging. So that's the kind of system how it works. And the measure then is on that discharge when that's happening. And that's what you can also see online as well. That data of whether it's discharging or not is published live, well, almost live. I could probably share a link for that if people are interested, because if you are something like swimming in the river and you want to check, is it discharging, you can go and see before you go there.
Okay, thank you. And yeah, I think it would be useful if we could pop that link in. Thank you, Jed. Next question is for Joe, and they said they love what you're campaigning for. Do you have a data set of the location of these highway runoff outfalls?
Yeah, so there is a map of the national highway runoff outfalls. So there is an old map that's available freely on Watershed Investigations pollution map. So that's published by a pair of journalists who got hold of an old copy of the map. So that's freely available. If you're lucky enough to work for the Rivers Trust or the Environment Agency, the Environment Agency certainly have a more up-to-date map of all the national highway outfalls on their GIS system. The Rivers Trust have just recently published a map of all the highway outfalls that National Highways have committed to fix in the next 5 years on their mapping system. I'm not sure if they've got the map of all the other outfalls. You can ask National Highways, you can do an FOI request for outfalls in your local area, and they will usually respond. But for all the other highway outfalls from the local authorities, there is no map. But people get hung up on that, but actually you don't need to, because actually whenever a road crosses a river, there will usually be an outfall. So for Preston, for example, I can look at the map of Preston and where the roads cross the rivers, and I know that if I go to those locations, I will almost certainly find an outfall. That's more complicated if you're on chalk or aquifers and permeable ground, but for those of us in Lancashire and Yorkshire, it's relatively straightforward. But if you want the watershed map, I'll try and put a link to that in the chat afterwards as well.
Great, thanks, Joe. So next, we have a question for both of you to answer. So bearing in mind Jed's comments that catchment level partnership working isn't mandatory, what are your thoughts on what a regional systems planner's powers might need to include as when DEFRA creates these? Is the DWMP Cycle 2 requirements for water and sewage companies to report on what they're doing in relation to urban transport-driven RNAGs, essentially encouraging cross-sector partnership working enough?
I'll take the second half of that first. I am delighted to see recognition of urban transport pollution in the DWMP Cycle 2. It's not enough, but it's a huge step forward from where we were before. And it also aligns really nicely with the recast Urban Wastewater Treatment Directive, which covers European member states. And they are also being required to think about the quantification of pollution from urban and highway transport, highway pollution in their new integrated water management plans, I think they're called. So that's really nice because that aligns us with Europe a bit, which I like, because that's where the Environmental Quality Standard Directive comes from. Is it enough? I think it's definitely more than we had before, and therefore it's good. And I hope in cycle 3 of the DWMPs there will actually be a plan in place to provide treatment at some of the surface water sewers which are grossly polluted with highway runoff. There's no requirement for that in this cycle, but I hope there will be in cycle 3. Sorry, Jed, do you want to come in that half of the question, and I'll come back to the regional systems planner?
I don't know. I've got much more to add on that one, Joe. I mean, I think my point on catchment partnerships is more around money. You know, it's we're putting all this money in, and you know, we're all paying for it, right? We're all paying increased water bills and everything else, and that's being put into the things we, you know, I think we all want is for it to be spent on, you know, reducing, making rivers better. Essentially, that's what we're doing, right? With that money, but I feel like you could sometimes get a lot more from your money by putting it into catchment level partnerships. And I think that's what some projects have demonstrated, but it's harder to quantify the benefits, I would say, on some of those projects.
So Adrian, to come in on the regional systems planners' powers, I'm with you. I don't know how that's going to work, but I've spoken to DEFRA and they have promised me that those planners, whoever they might be, will have a duty or a role in pollution from highway runoff in their region. But I don't know, like you, what form that will be. Will that be some sort of regulatory power, or will it be a power to make the regulators the new regulate? I don't know. I don't know. It works really well for mine water discharges already. So there's already a fairly mature system for delivering treatment at mine water discharges, where the coal authority prioritise those nationally, working with the Environment Agency, and then deliver schemes on a national priority. But obviously then when they come into an individual region and area, they work then with local teams to deliver the solution. So that's a good model for me. Prioritise nationally, but deliver locally. But I don't know how they'll have the powers to do that. I don't know. You know more than me, probably.
Thank you both. Next one for Joe. Is there anything we can do to pressure the EA to make sure this highway runoff is regulated?
Yeah, because further down there's a question about why does this not get any press coverage, and the two things are aligned. We just need to talk about it, put it on your socials, go out in the rain and take a video of a highway outfall causing pollution and put it on your socials. Nobody ever sees them because nobody goes out when it's raining. You don't walk the dog when it's raining. You don't go out and take your kids out to play in the local environment when it's raining. The more of us that go and do that, the better. And also go see the outfall polluting and then report it to the Environment Agency as a pollution incident, because we need to shift that dial on their pollution data so that the huge number of sewage pollutions that are reported to them under Operation Self-Monitoring outweighs everything else. But we can shift that dial by reporting more highway runoff pollution incidents. So go out in the rain, complain to the local environment agency, but also tell your MP. I've got a meeting with an MP next week. I've got a meeting with another MP in a couple of weeks. There is a little bit of movement on this topic, and we need to take that momentum and run with it.
Thank you, Jo. Next question is, would it be possible to explain in more detail why a national solution is not feasible and why it is quoted to cost so much more than individual water companies working towards a solution?
Yeah, that's referencing the cost of separating all surface water from sewage drainage. I guess the reason is just the complexity once you get into individual catchments is you can't really just apply the same solution on each one because it's not effective. I mean, a big part of what you want to do is actually stop the water getting into the sewage pipes on the separator system. So going back to my example, when at Watlington, when it rains, we see that increase in flow at the sewage treatment works because water is getting into the sewage treatment system. The way that happens is really complicated. There'll be infiltration. That's probably the easiest one to deal with. So that's when you've got water coming into the pipes, either because they're old, they're perforated at the joints, etc. Then the more complex ones, for example, are where you've got connections into the sewage system which shouldn't be there. So, for example, someone's built a house and connected to the wrong pipe. So the runoff from the drains or the housing, the gutters and everything is going into the sewage system instead of into the surface water system. Now, sometimes this is by mistake, sometimes it's corner cutting. It's very difficult to trace and then very difficult to resolve. So that's perhaps just a couple of examples of why a national solution perhaps isn't viable. And I guess the other thing is how the system's set up, right? The water system, the water industry is broken down into all these regional companies, and they're all responsible for their own assets, and the complexity of getting them to work together. It's easier to just set each company its own targets and for each company to deliver its own solutions specific to where they are. I mean, that's how we work at the moment.
Thanks, Jed. Next is one for Jo. So if the WFD classification points are so far away, would this render source apportionment tools like SAGIS less accurate to get an idea of highway runoff?
Yeah, so SAGIS is poor for. It's a long time since I've done any work with SAGIS, so I apologise to anybody who's updated it. It's 10 years since I left the agency, and 10 years probably before that since I looked at SAGIS. But when SAGIS was originally built for PAHs, there was no data on PAH pollution from highway runoff, and so as far as I was concerned then, and like I say, I don't know if it's changed, SAGIS was flawed when it came to assessing the sources of, apportioning the sources of PAH pollution across a catchment. So theoretically, source apportionment tools like that could work, but at the moment they have too little information on the level of pollution from highway runoff to make them effective. So even for copper and zinc, there was a better understanding of pollution from highways for copper and zinc when the model was built, but it wasn't up to date. So I'd love to see SAGIS rebuilt and rerun for copper, zinc and polyaromatic hydrocarbons, just in case anybody's got a bit of time on their hands. But theoretically, it's a good tool.
Thanks, Jo. Then this next question. So, Jo, you have mentioned some mapping, but it's been asked if there's a national map which covers all of the outfalls going into our river networks.
Yeah, so again, I'd point you to the watershed investigations map because that has a map layer of all permitted discharges. So all wastewater treatment works, industrial estates, industrial discharges, landfill sites, anything that's got a permit, there's a map layer that shows you where all permitted discharges are. Like I say, that doesn't cover highway discharges because they're not permitted, but it does. It's quite a useful map layer. I will share that when I can work out how to do it.
Yeah, thanks, Jo. Next, another highways question. Why do you think the impact caused by highway pollution and lack of legislation on highways, etc., is not covered so widely in the media? It seems water companies are scapegoated and blamed more excessively than others.
Yeah, I mean, I completely agree that the anger and the noise and the vitriol targeted at the water companies is unreasonable, I guess. Interestingly, somebody's asked a question further down onto why members of the public don't understand that 6 times dry weather flowing to a wastewater treatment works is probably good enough, and the rest of the sewage overflowing into the water environment when it's raining is possibly fine, and in some catchments it is fine. It's that whole thing, isn't it? How do we educate? How do we get the public to care about highway runoff? It's not as, the photographs and videos of poo floating past a surfer, or it is so emotive and so we're almost it's almost born into us, isn't it, to be repelled by poo. But that's not true of highway runoff, because nobody can see it, nobody can see the harm. So I think that's part of our problem. And also there's a political will amongst some of the activists to just hate the water companies because they hate capitalism, and we can't fix that. I can't fix that on my own.
Thanks, Jo. Another one for you. Do you come across issues with risk assessments when sampling in heavy rain? And does this cause a bias in the data if you can't sample in the worst weather conditions?
Yeah, absolutely. I mean, I personally don't have too much trouble with risk assessments. I've got expensive insurance and all the necessary equipment to sample. I've got a 3 meter sample pole, so I don't have to get too close to the water and all that sort of thing. But it is a massive problem when you're trying to get citizen scientists to do this work. Thames 21 tried to do a project a couple of years ago where citizen scientists would sample highway outfalls in heavy rain, and it it is a problem. It often rains hard, and I can tell you this from experience, at about 3 o'clock in the morning, which is a pain, and you can't send citizen scientists out in the dark at 3 a.m. to scramble down riverbanks. So yes, it can be a problem.
Yeah, thank you. So a question for Jed. How are Thames Water considering contaminants of emerging concerns such as PFAs, pharmaceuticals, microplastics, and AMR genes in relation to their impacts and mitigation?
Yeah, good question. This is the next big issue I would say that's going to be facing us. PFAS, if you've not heard of that, these are essentially sometimes called forever chemicals. Really, really recognized as a huge problem in America, not so much over here, although the issues are the same here. And they're things like, good source examples like Teflon on your non-stick frying pan. The chemical, once it's in your body, doesn't break down. Nothing breaks it down. So that's why they're kind of called forever chemicals, and they're regarded as being obviously fairly awful, I would say. At the moment, there's no regulation on them. It's coming, I feel. What are we doing at Thames? We've got an innovation project underway to research what we can do. How do you treat this stuff? How do you remove it from water? And I think we're partnering with Severn Trent on it. So it is something that everyone's recognizing. Yeah, so it's a good one. I'd really keen to, well, work on it in the future. I'm sure I will be, because it's something we're going to need to deal with.
Yeah, thank you, Jed. Next question is for Jo. Is there regulation that determines who is allowed to discharge highway drainage to watercourses? I know that developers have to jump through various hoops to be allowed to connect to the sewer system. So I was wondering if there is any similar regulation for highways drainage.
Yeah, so it's slightly different. Highway authorities have the right to discharge their highway runoff into the water environment. So that's quite unusual. So they have an absolute right to do that. They still have to comply with all the riparian stuff. So they have to get landowners' consent, and if they need to put an outfall in, they have to get a land drainage permit for their outfall and things. So that still exists. However, that right to discharge does not give them a right to pollute. and that's where I get involved. So the legislation says they can discharge their highway runoff into the water environment, but the legislation also says they can't cause pollution. And therein lies most of my work, because I spend my life fighting that they are causing pollution and they should fix it.
Thank you. Next, I think this question's for Jed. How do we educate the public to understand that water treatment works can't accept all flows, both rain and sewage, as trying to size a sewage works for DWF and in excess of 6 DWF is unrealistic, and the only current allowance is to allow the consented storm overflows to activate and storm tanks settle solids, etc., before allowing the storm tanks to overflow to the watercourse rather than flood back into people's houses?
Yeah, I mean, I think Jo touched on it earlier, didn't she, around the emotion around sewage. And I think that's kind of what is driving a lot of it. Like you say, nobody wants raw and treated sewage to be going into rivers. It's just fundamentally something you don't want to be happening. And technically, feasibly, if you put enough investment, enough into it, enough upgrades, you can pretty much. Oh, goodness knows how much it'd take to eliminate it. But nothing's impossible from an engineering perspective, is it? With enough resource. But is that the best use in terms of reducing the environmental impact of sewage? Probably not, right? You're better dealing with all these other issues, improving the quality of the effluent that's coming out on a day-to-day basis, rather than just the storms. I mean, it's obviously better to do both, which is what's happening, right? And I think the other thing with it is educating how a storm overflow and the sewage treatment works. It's complex, right? I don't know. I mean, where do you start with that?
And I think as well, you've lost the narrative because of what's happened in the last 5 years. So if you try and say to the public now, well, we're taking 6 times dry weather flow to full treatment, and we're doing storm settlement for up to 12 times dry weather flow in the storm tanks, whatever, and then what discharges goes in when the river's in spate and it's already settled sewage, and nobody will listen to you anymore. They just go, oh, you're all trying to kill us all and you're pumping sewage into the rivers. And so you've lost that narrative, and that's a damn shame. Hard luck.
Yeah, thank you both. As we've only got 1 minute left in kind of our time slot for this webinar, just going to do one final question, and the one that's got the most upvotes of the ones left. So just for you, Jo, do you know if railways are polluting as highways for runoff? And if, like highways, there are likely outfalls when they cross rivers?
Yeah, so railways historically did cause pollution. None of you are probably old enough to remember when the toilet in a train just literally dropped the toilet's waste onto the train track. So they did used to cause pollution. Thanks, Jed. It's not just me. But it's not as bad as highway pollution. There's some metal off the tracks and the wheels. There's some hydrocarbon because there are lubricants on trains, but not very many trains are diesel fueled anymore. So it's less polluting. And theoretically, the ballast under the train operates the same function as a trickling filter in a sewage work. So you get micro biofilm growing on the ballast, and they go blah, 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 and eat all the pollution. So it's less of a problem, but it is still a problem. I'll do that next, if that's okay. I'll fix highway runoff and then do railways if I'm still working.
Oh, thank you, Jo. There are still quite a few questions. So I was just wondering, would both of you be happy if people wanted to contact you with their questions following the webinar?
Yeah. Yeah.
Brilliant. Thank you. So if we just pop on to the next slide.
Lost control of everything. Anyway, I will try in the meantime to work. Okay. I'm already doing that. I think I've broken it. No, I don't want to share that. I am sharing it. I don't know how to go forward. I'm sorry.
That's okay. Just a note for everyone, if you go onto the CIWEM website, you'll be able to see all the upcoming events over the next few months and be able to sign up to those there. But thank you everyone for joining today, and a big thank you to both our presenters, Jed and Joe. So, yeah, thank you all.
Thanks.